right, so parallel and perpendicular lines should not be a new concept for you, but I think they probably will be a new concept as far as looking at equations. So parallel lines you should have heard of before. They are lines that are equidistant from each other at all points. What's equidistant mean? Okay. Equal distances, right? So equal distances apart at all points. These lines are never going to touch. I guess I should, if I was really being technical, if I was going back to my geometry days, technically you could have lines that are not equidistant that never touch. Anybody think they can? How? How could you have two lines? How could you have two lines that are like not the same distance apart all the time, but they also never touch? No, I'm still talking about straight lines here. So, you could have. Oh, yeah. You want a Ziploc bag?
Yes, please. That's what's making my book bag black. That's not too good.
Alright, so see if it'll fit in the Ziploc bag here. Alright. Okay. Can anybody think about this? How could you have two lines that never touch, but they're not the same distance apart at all? If you have, like if I could have two lines that look maybe like this and maybe like this. They don't touch right now, but would they eventually touch? Yeah, they're going to cross eventually. So, the geometric definition of a line goes on in both directions forever. So, geometric definition of a line is that they extend in opposite directions forever. So that's why when we draw them, we put those arrows on the end of them. So there are lines that can never touch, though, that aren't the same distance apart. Okay? Think about the back corner of this room. That back corner. Imagine there's a line that goes vertically in that back corner, right? So it would keep going up through the ceiling into the sky. It would also keep going down through the library, down, forever. We got that back corner. Okay, so you got that line. Would it ever touch the line that is at the top corner of this ceiling, the horizontal line at the top corner of this ceiling? No. Okay, they would never touch, right? Because this line right here and that line right there are not in the same plane. What's a plane? We call the graph that we have right here the coordinate plane. A plane is a flat surface that extends out forever, right? So the coordinate plane, like the XY coordinate plane, in that plane, any lines that are equidistant from each other are going to be lines that never touch. They have to be parallel if they're both in that plane. But if they're in different planes, so if you have this wall right here is one plane, that wall back there is another plane. So those lines would not be equidistant, but they would also never touch. They're called skew lines. That are in different planes. But in this class, we basically only work in the XY coordinate plane. We don't work with 3D stuff in this class. That's some geometry stuff that is true. So I guess we should, if we want to be technical here, though, we should probably add in lines in the same plane. That never touch. if we want to be really precise. Because skew lines are a possibility. But that's just a side note there that from my geometry days I felt like I needed to clarify. Because when I first came here, I taught mostly all geometry for the first several years that I taught. But then they chopped geometry into tiny little pieces, sprinkled it into Math 1, 2, and 3, and destroyed it. It is sprinkled in 1, 2, and 3. So we do a little tiny bit in Math 1, not much at all. And then we do your trig stuff, most of your triangle stuff in Math 2, and then your circles and some other stuff is in Math 3. So it kind of like mixed it all up. I don't like it. I like it better whenever geometry is all together. But they didn't ask me. They just changed it. And when I say they, I'm talking about like the state, not anybody here at the school. We don't have that power to choose the curriculum. So geometry was one of my favorite classes to teach. Perpendicular lines, you also should know about this. There are two lines that form a 90-degree angle, or we could say that form 4 90-degree angles right here, right? Because if this angle right here is 40 degrees, all 4 of those angles right there would be 90 degrees. So you guys are familiar with that term perpendicular, aren't you? Okay. All right, so I have here, I think, 8 graphs. Yes. All right, so what I want you to do is we're going to do the first one together, but then you're going to do the rest of these on your own, and then we'll check and see how we're doing with them. Is we're going to graph these 2 lines on the XY coordinate plane, and then we're going to decide whether they look like they're parallel, perpendicular, or neither. So I have got y equals 2/3 x minus 4, and so that has a y-intercept at -4. And a slope of 2/3, so up 2 to the right 3, up 2 to the right 3 here. Please graph these all the way out to the edge and graph them one at a time. Do not try to graph the second line until you've already graphed that first line, or you'll get all your dots mixed up. Okay, so that is our graph for y equals 2/3 x minus 4. I'm going to use a different color for the second one. For the second one, Haley, what's our y-intercept for that second one? Y-intercept, that's 1. Okay, and then what is the slope, Haley? Okay, so from this point, what should I do? Okay, down 3. And then what? Good. Down 3, right 2, down 3, right 2. I could also go up 3, left 2 to finish drawing out this line. All right. So when we look at those, are they parallel? Definitely not parallel. Are they perpendicular? I think so. And you can kind of check. Right now we're going to learn a way to know for 100% sure. But right now you can sort of just check by seeing if you take like the corner of your paper or a corner of a paper and put it right there where the 2 lines meet. Does it, fit? Mine's not perfect. I think that's probably due to my poor graphing and not to it looks pretty good right here. It's a little crooked right there, but I think that's my fault. So you can see that looks like it's a 90-degree angle right there. So for this one, that looks like a 90-degree angle. We would say perpendicular. Okay? So you're going to do the same thing for the rest of these 8. Well, we did 1. The rest of the other 7 graphs here that you have, you are going to graph both of those lines and then decide if you think they're parallel, perpendicular, or neither. Okay? So go ahead and do that for me. I'm going to do mine up here, but I'm going to cut the screen off so you guys can't see. So go ahead and keep working. You're going to go all the way through example 8. Whenever you get to example 4, can you graph those the way they are? Have to solve for y. So make sure whenever you get to those that are not solved for y, that you solve those for y. Okay. Would you guys agree that this is parallel?
Yeah.
Okay. Does yours look parallel on your paper? I hope for number 2. Okay. All right. For number 3, you should have these 2 graphs here. Should look something like this. And those look perpendicular to me. All right here. All right. 4, you actually have to solve these for y. So for the blue graph that I have here, when I get it solved for y, I get y equals 3 minus 2/3 x. And so that's this blue graph right here. And then for the red graph, I get y equals -5 plus 3/2 x. And that's this red graph here. Parallel, perpendicular, or neither? Perpendicular. Okay. For number 5, the blue graph, whenever you solve it for y, you should get y equals -4 plus 4/3 x. The red graph, you should get y equals 2 minus 3/2 x. When you graph these, they look a little perpendicular-ish, right? But perpendicular has to form an exact right angle. So if you were to take like the corner of your paper and try to fit it in this angle right here, it's not going to work exactly. So we would just say that's neither right there. So 2 lines crossing is not necessarily perpendicular. If we take our rectangle, like our quarter of our paper here, and let me turn it. Let's see if I line it up with that red line right there. Does it fit in between there? It does not. Okay, so that would not be perpendicular. Okay. All right, example 6. Blue one's a little bit tricky. It's already solved for y. They just put the y on the right-hand side, which we don't usually do, right? So the y-intercept is 8. The slope is -1, and you can just graph it from here. The red one, you do have to solve that for y. You get y equals 4 minus x. You got a y-intercept of 4. The slope is -1. Parallel, perpendicular, neither. Let's see parallel here, right? Okay, questions?
How did I get this?
Point to which graph it is there.
It's 6. I got perpendicular.
that means you like did it.
One of the lines, the red line is right. I don't know how I got that big.
You have it increasing. Did you solve it for y?
I might not have that.
Yeah.
I was trying to do
If
it
you just
by
looked
accident.
at the x and saw that 1 in front of it,
Because I got big green, I guess.
okay, you got to solve that one for y. There, you probably did not solve it for y.
Oh, I didn't do the -1.
All right, here's 7. Okay, whenever you solve that first one for y, you're going to get y equals 9 minus 3x. The second one is going to be y equals negative 2/3 minus 1/3 x. And those are intersecting, but they are not perpendicular. Again, they don't make that 90-degree angle, so they are not perpendicular. All right, and the last one, y equals 9 is a horizontal line. Here, you do have to solve this for y, so you subtract the 2. You get y equals negative 2. It's another horizontal line. Those are parallel. Okay, so what I want us to do, we did all of this graphing for a reason. One way that you can tell if lines are parallel, perpendicular, neither is you can graph them and look at them. That is a possibility. But it would be nice if maybe we didn't have to graph 2 lines every time, right? So let's look back, and if you already have made this conclusion, please do not shout it out because I want everybody to have a chance to think of it. Let's go back and look at the slopes on these graphs. So right here I had 2/3 for this slope, negative 3/2 for this slope. My lines ended up being perpendicular. There. Let's look at all the other perpendicular ones. Here's a perpendicular one, example 3. Had a slope of 2 and negative 1/2. And that was perpendicular. Okay. If you think you know the trick, don't shout it out yet. All right. 4 was also perpendicular. My slope right here was negative 2/3. And my slope right here was positive 3/2. That gave me perpendicular lines. Okay, those were neither one. I don't think I had any more perpendicular ones today. So if we look again, negative 3/2, positive 3/2. We had 2 and negative 1/2. And we had 2/3 and negative 3/2. Okay, so looking at the slopes here for perpendicular lines, what do you guys think? Is there a shortcut, a way that we can figure out these just by looking at our equations? Okay, what do you think, Savannah? Okay, what do you mean by that they're switched around? Okay, so they are flipped upside down, right? So if you had 2 on top, it went to the bottom. If you had 3 on the bottom, it went to the top. What else could we say about them flipping? Is it just flipping, or what else? The sign is also reversed, right? So where I had a negative here, I have a positive here. Okay? So let's think, maybe I should have looked ahead at the notes. All right, so perpendicular lines have slopes that are. Now there's fancy words for this. Did you guys do any parallel perpendicular lines in 8th grade? I don't think so. I think this is where we get into, I know you graphed lines in 8th grade, but I don't think you do parallel perpendicular. So, all right, so, yeah, if like perpendicular parallel probably is about 4th grade whenever you talk about the lines themselves. So, I don't think you do this in Miss Ball's class, but I could be wrong. So, there's fancy words. We said we need to flip and we need to change the sign. But there's fancy words for each one of those. Okay? So, the fancy words, perpendicular lines have slopes that are opposite. That's not that fancy of a word. Here's a fancy one, though. Opposite reciprocals. Opposite means change the sign. And reciprocal means to flip. So if I have a slope that is 4/5, what is the perpendicular? Slope. It'd be -5 over 4. Right? It's flip, change the sign and flip the fraction. Okay? Alright, so that's for perpendicular. We have opposite reciprocals. We need to know that. It'll make it much easier where we don't have to graph every single line. Okay? Now, let's go back and look at parallel lines. Okay, don't shout it out if you already know. Give everybody a second to think about it. Example 2 was parallel, and we had 1/3 for both of our slopes. 6 was parallel. We had, what was my slope for this one? For the first one. What is the slope of that line? It is -1. It's whatever's in front of your x. There's nothing there, so we put a 1. Right? So -1. What about down here for this one? What's the slope? Also -1. Well, I think this one's going to be easier to figure out than the last one, don't you guys? Let's see. Highlighter. So -1, -1. This one right here, these were parallel. Oh, I can't really highlight the slope on this one. What's my slope of the blue line? What? It's 0. Right? And the slope of the red line? Also 0. So, conclusions here, parallel lines have the same. I really should, though, say parallel lines have the same slopes. Let's add to this. And different y-intercepts. Because if they have the same slope and the same y-intercept,
It's just going to be the same.
it's just the same line, right? So they have to have different y-intercepts. Can perpendicular lines have the same y-intercept?
Yes, they can.
It's okay for them to have the same y-intercept because, like, if I just think of graphing that. All right, somebody, Haley, give me the equation of a line, any line. Put an X with it. Make it a slanted line. Okay, put a y-intercept with it. I mean, it has one. It's 0 right now, but give me one besides 0. Okay, so I've got y equals 2x minus 2. All right, who can give me the equation of the line perpendicular to this line that has the same y-intercept? Okay, Evan?
-1/2 x minus 2.
Okay, you guys agree? Okay, this slope right here is 2/1. If I flip it and change the sign, so it's okay for perpendicular lines to have the same y-intercept because they don't have the same slope. It's not the exact same line. But parallel lines cannot have the same y-intercept because if they have the same y-intercept and the same slope, they're the same line, and then they touch everywhere. Okay, so all right. we have several questions here. For 9, it says find the slope of the line that is parallel to y equals 3x minus 4. Okay? So, Aiden, what would we get for this one? Yes. That is the equation of a line that would be perpendicular to this. What does this one ask us for?
Parallel.
Find the slope of the line that is parallel.
Oh, yeah.
Alright, so what would our answer be, Aiden? I don't like the x with it, just 3. Okay, slopes, although they are beside of the x, you don't include the x whenever you're given the slope. There, so parallel lines just have to have the same slope, so that would just be 3. Okay? Alright, so 10 asks us to find the slope of the line that is perpendicular to 3x minus 4. So, Caitlin, what would we get for this one? It's almost the same question. It's still asking us for the slope, but this time it said perpendicular. What? -4? No. What is the slope of this line right here? The slope of this line right here is 3. I'm going to call it m equals 3. Alright, now, I'm going to use this symbol right here, an upside down capital T. That symbol is a mathematical symbol. It means perpendicular. Mathematicians don't like to write out long words, so they just create symbols for them. And when I put upside down TM, what do I mean right there? What does that mean? Perpendicular. So mathematicians like to avoid words, so we do things like this. So if my slope is 3, it would be -1/3. That perpendicular slope would be -1/3. So that would be the answer. Perpendicular, what you're going to do for perpendicular is whatever your original slope was, in this case it was 3, you are going to flip it and change the sign. Since it's not a fraction right now, we just put it over 1, and then so you're flipping that, so it's 1/3, and then you have to change the sign. Since it was positive, we make it negative. Okay? Alright, Ian, what would we get for number 11? Find the slope of the line that's parallel to y equals 1/2 x minus 4. Okay, what's it asking for? Okay. You give up easy, Ian. So, what's the slope of this line? And don't include the x whenever you're given slope. So, just 1/2. And so, the parallel line would be also 1/2, right? Yeah, same slope for parallel.
Oh, wait, that is right.
Yeah.
They have different.
Right. Different y-intercepts. And this one didn't ask anything about a y-intercept, so we would just, all we got to answer is slope. All right, Ian, what about if it says perpendicular? So this is basically the same question, but it says perpendicular. Almost. What have we got to do for perpendicular slopes? What was the fancy word? Was opposite reciprocal. So we are going to take 1/2. We're going to flip it. That's going to make it 2/1. But what else have we got to do to it? Make it a negative. You got to change the sign. So -2/1, or it would look better if we just put -2. Okay. So for perpendicular, we're going to flip it. We're going to change the sign. Okay. Parallel, just the same slope. All right, so 13. Are these lines parallel, perpendicular, or neither? Okay, so, and does yours have a negative drawn in right there? It does, okay. All right, so, the first equation, Blakeland, what's the slope of that first equation, y equals 8x minus 4? Yeah. 8, right? So our slope right here is 8, right? It's already solved for y, so it's just the number next to our x. For the second one, that one is not solved for y. So Eddie, this is your favorite thing to do. How are we going to solve that for y? There's a negative right here that I added in, so we will add it. It's handwritten because I guess I changed my mind on that. Alright, so y equals 1 plus 8x. What's the slope of this line? Is also 8. So if they have the same slope, but they do have different y-intercepts, right? It had -4 here, +1. What does that tell me about the lines? Are they parallel, perpendicular, or neither? Parallel. If they have the same slope, they're perpendicular. Think about parallel lines. Slope is your steepness. Parallel lines have to have the same steepness, right? If one line is steeper than the other, then they're going to cross, right? But for them to never touch, they have to have the same steepness. There. Okay. Kama, help me with the next one. That first one there, 2x minus 5y equals 10. I cannot tell what the equation, what the slope of that line is as it is. So what would I have to do for that? Very good. So I got -5y equals 10 minus 2x. Then what would I do? Got to get that y right there by itself. Perfect. Divide by -5. Alright, so y would equal -2 plus 2/5 x. So, Camel, what is the slope of this line? 2/5. Camel, what's the slope of this other line? 2/5. Are they parallel, perpendicular, or neither? It seems like they should be parallel, and I want to say they're parallel as well. But Isabella's paying closer attention than Kama and I. And she's saying neither. Why? The y-intercept right here is -2. The y-intercept right here is -2 as well. So this would be neither. Or I want to tell you another word that I think you're going to see on, I can't remember if it's today's worksheet or tomorrow. Coincide. I think a worksheet that you're going to see is going to call them coinciding lines. That just means they're the same line. They're one's on top of each other. So they're not parallel perpendicular because they coincide. They're the same line there. All right. Let's see. We're going to do this stuff right here tomorrow. Okay? Slopes. So if you have 10/8 and 5/4, those would be parallel because 10/8 reduces to 5/4. So if it's not reduced, reduce it.
How do you show that?
4 is not right. But the rest of them are okay. Think about what -0.1 would be as a fraction.
Oh, I didn't know it was a point.
Yeah, it's a 0.1.
Is this one like a typo or is it meant to be like a no y?
Huh?
Is it meant to no y?
Oh, it is probably a typo, but just go ahead and mark it like it is.